Welcome to Brain Vision.
In this question, we have to determine what is the magnitude and the angle that the acceleration vector makes with the horizontal axis. We begin by drawing our two reference axes, the y-axis and the x-axis, which coincides with the horizontal axis. Then, we proceed to decompose both forces, the weight and the thrust force, on the x and y components. How can we do that? Let me call this F, and for the weight we have W. And remember that the weight is equals to the mass times the gravity. Then we have 4.5 times 10 to the fifth times 9.8. Let's keep it like this for a while. Now we proceed to decompose the force F on both axes. How can we do that? Remember that for the x component we have the magnitude times the cosine of the angle between the force and the horizontal axis. For the y component, we have the magnitude times the sine of the angle between the force and the horizontal axis. Therefore, F component x is equals to 7.5 times 10 to the sixth times the cosine of 55 degrees, which gives us approximately 4.3 times 10 to the sixth newtons. Now, for the y component, we have 7.5 times 10 to the sixth times the sine of 55 degrees, which gives us approximately 6.1 times 10 to the sixth. Now, we know the components of the force F. Note that we already know the component of the weight force. It only has one component that points towards the negative y direction. Therefore, we can write it like that. The x component of the weight force is equals to 0, and the vertical component is equals to minus 4.5 times 10 to the fifth times 9.8, which is approximately 44.1 times 10 to the fifth newtons. Now let me summarize these results. Now we can use Newton's second law to calculate what are the x and y components of the acceleration. For the x component, we have the following. The net force on the x direction is equals to the mass times the acceleration on the x direction. Then, the net force on the x direction is equals to the x component of the force F. So 4.3 times 10 to the sixth is equals to 4.5 times 10 to the fifth times the acceleration over the x-axis. Then the x component of the acceleration is equals to 4.3 times 10 to the sixth divided by 4.5 times 10 to the fifth. This is equals to 4.3 times 10 to the sixth minus 5 divided by 4.5. And this gives us approximately 9.6 meters per second squared for the x component of the acceleration. For the y component, we have the following. The net force on the y direction is equals to the mass times the acceleration on the y direction. The net force on the y direction is equals to 6.1 times 10 to the sixth minus 44.1 times 10 to the fifth. And this is equals to 4.5 times 10 to the fifth times the y component of the acceleration. Then, the y component of the acceleration is equals to 6.1 times 10 to the sixth minus 44.1 times 10 to the fifth divided by 4.5 times 10 to the fifth. And this is approximately 3.8 meters per second squared. Now, let me organize the results. The magnitude of the resulting acceleration is equals to the square root of its x component squared plus its y component squared. It's just the Pythagorean theorem. And this is equals to the square root of 9.6 squared plus 3.8 squared, which is approximately 10.3 meters per second squared. So this is the magnitude of the resulting acceleration. Now, what is the angle that the resulting acceleration makes with the horizontal axis? Well, we know that the tangent of that angle is equals to the y component of the acceleration divided by the x component of the acceleration. And this is equals to 3.8 divided by 9.6, which is approximately 0.4. Then the angle is equals to the inverse tangent of 0.4, which is approximately 21.8 degrees. So this is the angle between the horizontal and the resulting acceleration. A drawing will be the following. Here is the resulting acceleration. Its magnitude is 10.3 meters per second squared, and the angle it makes with the horizontal axis is 21.8 degrees.